Okay, so the code explanation you've asked for. So I'll try to go through the program as it goes in IntelliJ. There's our main class. It's tiny. It's just to separate all the starting things and start the program. Then we specify the way to the common SVG config file. Then we do some logging and start our peer process. Actually, when we do this, we don't only create our config. In this constructor I have file reading, so we read our config file into one string variable and then parse it. There we have the previous seller implemented. It's config parse, and I just rewrited it that I is not now a global variable but local one. And there we have splitting by space bars or space symbols, if you want, name it how you want. And then we are just parsing some characteristics of the peers we need to create. And if we don't have anything great, we throw new legal argument and exception in case we will know that something in the config file isn't correct. Then we start the peer process. In the peer process we fill a bunch of local variables with config we've created before, calculate the total pieces by this formula, which just takes the all file size, divides this by fee size, and takes the nearest positive integer, the closest. And then we start with peers. We throw an exception in case we don't know what's going on with that peers if it fails. So when we start the peers, first we read the second peer config file, which in our case is peerinfo.cfg, and we split it by /n to get the characteristic for each peer individually. Now we know how many peers there are because there's only one string for each peer in this split array. So we just start a peer from each of these split array strings in this for loop. In this for loop we try to get individual characteristic of the peer by splitting the current line by spacebars. So we individually get this, and this as different variables in different indices in our string array named peer CFG. Then we parse an integer to get the peer ID, pass the hostname to get the peer hostname, pass the port as the integer to get the peer's port, and then we parse this final bit, which is 1 and 0, and we later convert it to boolean because it's just simply true or false, 1 0. But in the project files you sent me, it was 1 0, so I just kept it as it was. Now we create a new peer from all of these configs. What do we do when we create a new peer? We assign a bunch of local variables to have the direct access for them. Then we create a new array list of messages. I think we would need that later, but even not, why not? Then we implement a new peer message sender. Is another class for helping me to sending messages. It has a send message method, which is just Java writing of all of the things which are named in these extra messages in the project description. I just translated it into the Java code. All the byte arrays are assigned. All is great. Then we then in the peers we get an array list of other peers to know whether we connect to a peer we know or we don't know. It's because of the project requirements too. In this handshake we need to check if it's an appropriate neighbor, it says. Then we set all the configs for a peer. In this method we just simply pass all the configs, and if it has file we set all the bits in our bit field of the peer to 1. In another way, if it doesn't have any file, we just set it all of them to 0. Later we create files for the peer. These are all these peer directories. One directory named peer, whatever the assigned name is, I don't know how actually its name is, and the peer ID. And if we also remove the first peer directory, just in case it has left there anything from previous test, and we create it, and we create a new directory for our peer. If we are unable to create a directory, we just throw new runtime exception with this text. So now we can be sure that all our peer directories are created and are available for writing. Then we set up our peer socket. It's just a small method. I think I will remove it, but it's pretty comfortable to use such small methods for setup, so I probably leave it as it is. And then we have only start communication method, which is more interesting. In this start communication method, we create a server socket for our peer. How it works is it's now a socket that automatically powers on your computer. So the address of the socket will be the address of your computer, or localhost if you want to use it in local network. So it would be this address. It's the address of your computer in your network by default, or if you like letters more, localhost. You can connect to this server both by localhost and by this number address I showed you before. So it just creates a server for a peer to listen the other peer's connections. And then we start a peer thread for each peer. We try to connect to it, and we start a thread for it. And then we start a server thread to handle other peers' connections. First I will explain the server part because it's easier. First we have a peers choke and choke thread, which I have all the structure and comments implemented, like calculating the load rate, choosing one of the previous neighbors to choke, etc, etc. It's all just in comments now, no methods extra are implemented. And we do it, and then we sleep unchoking interval for 1000 L because we need to sleep in long. We could just cast unchoking interval to long if you want, but I'm pretty comfortable for constant literals like L, D, and other ones used in Java. And we sleep because we need to do it k seconds. We need to do every p seconds, and this p is actually the unchoking interval, which is given at the start of the program. The first seller, by the way, thought that it is given in the command prompt, like when you run this program. When you run this program, you don't need to type Java main and some arguments after that. You just type Java main and it reads all from the config. The previous seller thought that we need to type Java main and then type the number of the seconds we need to want before choking and choking. I implemented it like this. So we just start a new thread for it because it needs to be separate from all the structure of our project. Then we start a TCP phone, I'll explain it minutes later, on this server, and we just handle messages from it. I will explain it soon. So the next thing we need to do is start a thread for each peer individually to communicate between our peers and the second one. We just connect to it using its hostname and peer port and handle messages with it. As you can see, handle messages method is pretty similar to the server handle messages method. In fact, it's the same method. The only one difference is in parameters. When we start a peer thread, we suppose that we are connected to that peer, so we know anything about it. When we go to the server method of handling messages, the actual handling messages method is, we can see that we have null as a parameter for a peer here. Let me write that. So if this parameter is null, we can know that it's a peer that had connected to us, not we connected to it, but it has connected to us. So if we go to handle messages method, what is there? Some variables for later. A message, which we will receive later. a message is just a simple structure with a bit field, message type, length. Oh, actually it was from the previous slide when we tried to send it through object out of stream. Now we can just remove all that. It's not longer necessary. So if peer is null, we already know that if peer is null, we have this peer that connects to us. So this way we know that its handle messages was called from the server thread, and we need to handle messages as if we're the server. Else peer is not null, and then we are connected to that peer. We were the peer who wanted to connect. Then we send a handshake message. I just made a great method for it, which just passes the client. There's client socket. This TCP phone is actually the class for handling sockets, which has two data output streams, data input stream, data output streams. It has two constructors for the peer we want to connect. So if we want to connect to something, we just type, new TCP phone, and we get the address, for example, localhost 666. It now means that we had connected to the server on our machine, which with port 666, and now we can actually send data to it, like written and writing bytes. So we can close and exit. It's just a pretty comfortable class to use. And if we want to our server handle, we want to our peers to connect to it, we just pass in not the address and the host we want to connect, but the server socket, which waits for a client to connect and then assigns these writer and reader similarly. We have a getIP method for, I don't know actually what it is, I think it's only for logging. Reading bytes, which just reads bytes into byte-array, and writing bytes. This flash here is because all the things are buffered, so they don't write bytes directly, they write them into a buffer, and when the flash method is called, this buffer is sent in one piece. So that way we don't need actually know how much bytes we receive. Closing, I will implement it later, and equals for, I don't know, 4 actually, and some string method for logging. Anyway, so we just, into our handshake method, we pass in this, in fact, socket client, and we pass a peer to handshake to get its properties. Now, we send a handshake to that peer. As a sender, we assign this, because we, as a peer, this is not a static method, so it can only be called by the exemplar of this class. So we just pass in ourselves as the sender, and we want to send handshake to this client. How do we send a handshake? It's a method in peer message sender. We get a bit field, bits, 32 bits. We assign the bytes from 0 to 17 included. P2P file sharing proj, we're getting bytes from the strings and chances UTF-8. It's a standard string class method, which allows us to convert a string into an array of bytes. This is actually specified right in here. 32 bytes, the first 18 is 80 byte string, P2P file sharing project, there it is. The next one are 0 bytes, so we just sent bytes from 18 to 27 included to 0. And the last 4 are our peer ID, so from 28 to 31 included, we just sent our peer ID. There's the one of the method I created in my utils class, which creates a byte array from int. It's just the byte buffer. Also, we have an integer from byte array in here. All these byte buffers have a big endian by default, so if we have like ff integer, you know about the hexadecimal. 0xff is the way to handle hexadecimal in Java. If we have AA, it's written to the byte buffer as FFAA, just to the 10th radix. And if we read from it, we assume that first we have the more valuable bytes, then we have the less valuable. So 123 would be written as 123, not as 321. it's just about endians and it's by default great. But if you want, you can actually use byte set. I think, don't remember how this method was named actually, like endian or something like that. Put mismatch, put float, rewind, slice. I don't remember. Anyway, there is the method for powering it up. Now let's continue with our handshake method. We just get a byte array from this bit field, and then we just send it using our write bytes method from TCP phone. Log something, and we return true if we successfully sent a handshake, and return false if it was a failure. It can be a failure just because we aren't even connected to something. So now we know that we have handshaked. We check it, throw a runtime exception if we really didn't. Then we have a receive handshake. We know it's exactly 32 byte long because of our project specification. We now just waiting for a peer to receive an answer. Read bytes isn't actually one of the methods that are called waiting methods. It stops all the program, all the thread until we got the bytes. So we just read them, and if we read bytes, returns the number of bytes we have read. It's just from read to read, and it returns the number of bytes read. So now we have our 32 byte array read. If it's not 32, we assume that we have received the wrong message, and we throw a new runtime exception. I'm throwing runtime exceptions everywhere because everything needs to work perfectly. So if we throw a new runtime exception, we get, this pretty stack trace where you can go just, let me see. I can just, change this to, for example, 2033, which is incorrect. And now if I power it up, we can see that it tries to pair, and it throws me a runtime exception. We failed to receive a handshake message. We see all of the exceptions we need, and now we can just it tells us in what exactly line it happened. It's important when you run it from the command prompt, because in command prompt you don't have this system error stream. You have just a system output stream, and these runtime exceptions are thrown directly to the output stream, so we can see them even if we're in console. So if we failed to receive this message, or if we just received the wrong number of bytes, we fail. Then we know that we have received an appropriate number of bytes, so we check our handshake. How do we do it? We can just get the P2P sharing proj header from bytes to 0 to 80 byte string. We form a string using the standard string constructor which can be made of bytes. Use equals for checking if we have a correct header, and if we have a correct header, we just form indices. We just form an integer peer ID from the last 4 bytes we have. This received, even if a peer is null, we pass the peer we wanted to connect in here. So if it is null, it just means that the peer has just connected to us. And now we have all the information about it. I will implement later a variable for each peer. And if peer is null, we just return true because we don't have any information about this peer. So now we have its ID. If we were trying to make a connection with this peer by ourselves, we know that we want to have a received ID equal to our ID we have already, the ID of the peer we tried to connect it. So we check. These, by the way, needs to go first, because if we change, it means that we just try to get a variable from a null object which can reproduce null pointer exceptions. So we just need to make it like that, because if it's null, Java doesn't check this. So if it's 1 or 0, it doesn't check 0. So it's impossible for us to get a null pointer exception. It's actually a pretty useful trick. So when you want to, if you, for example, implement something with integer division by 0, and you just return a is 0 or something divided by A is B, you can, when you go to this condition, you can already know that you won't get integer division by 0 exception, because you've already checked that A isn't 0. It's a pretty useful trick. So now when we check a handshake, we can just return it. And there we have it. Now we know that we have successfully handshaked or it's a failure. We log it, and then if handshake has failed, and there it is, all our structure I previously made with comments. If we have a handshake, if we had handshaked, and if we have file, we just send a bit-filled message to the other peer. And we receive an answer. If its peer is interested or not interested in this method, we just send the appropriate messages. Then we start in infinite messaging loop, as it's like said in there. After handshaking, each peer can send a stream of actual messages. There it is. We receive a message. Then depending on its type, we can just do the actions all we need. And that's pretty much it, all the program. I didn't really mention all of the aspects, like message type, enum, where we have like this small enum of values corresponding to each of message types, which is actually just a copy of this table right here. So unchoke one, there it is a pretty good way to handle constants. Actually, it's done in the protocol interface, right in there. I don't really think I need this protocol interface, but I will leave it for constants later. We have this get by value method. I copied it from Stack Overflow. Actually, I really understand how it works, but I was too lazy to implement by myself in my own. We just go. I didn't really know that in all the enum we have actually this values method, which allows us to get all these constants from the enum we have. So it just returns a list of them, and then we iterate through it, and if we have a corresponding number value, we return this message, else we return a null. So now we can get, if we type get by value 3, we get a non-interested type of message. And it's pretty useful because we can switch through it, and it's actually how it's done in there. It's pretty much clean code. You can see that case choke is, you switch in message get type and you just see case choke, and you received a choke message. You can actually handle exceptions in there. So if we request a message, and if we request a message when we're choked, we throw new illegal state exceptions, because it's not the behavior we want to expect. Also, if we received some different message types, it can be when other student peers can connect to us and they have their wrong specification, wrong types. We can just throw new illegal argument exception or wrong message type received. And if we failed handshake, we just leave working thread immediately because our handshake failed. So there it is. Oh, check out my small rainbow brackets plugin. Actually, it's very comfortable to use. You can just immediately look up your code and see where each of the pair of brackets end. You can usually just throw a cursor on this near it to see it, but I think it's more comfortable to have this rainbow one. And of course it works for all of these inside brackets, as you can see right here. It's pretty comfortable when you use like a ton of method calls in one string. So that's, I think, all for it. If you have any questions, you can ask them. I think this video will be more than 5 gig size, so I will try to send you it in an archive to Stormo space, because Fiverr implements only 5 gigabytes of file size. Or I can just upload it into my YouTube channel. I don't think you are really interested in my YouTube channel, but in case, please subscribe. So thanks you for this small project. It's actually the midpoint check now. It has, let's calculate the statistic, just remove the test class, which has all the code from your partner, one of the group members. refresh Java total lines. We have now 1000 lines, and source code lines is 801, so we passed the midpoint check. It's just source code lines. As you can see, if I do something like that, it wouldn't increase source code lines at all. So it doesn't depend on which thing we think. So actually, as you can see, source code lines didn't change. So it's like the lines. For example, it thinks that this all is one line, but I'm pretty comfortable to write it like that because it looks prettier and understandable. So thanks again, bye.